Welcome to a discussion of method development, specifically quant method development and using a library-based compound identification methodology. In the previous section, we went over the library method and the parameters that drive this library pipeline producing library results. In another technical video, there is an explanation of the automated tools available in the quant method menu that allow you to create a quant method. A number of those tools rely on library search. For example, scan data with library search, or the append version of that. A comment on method development: if you've got the standards and you're injecting them and they are in a library, then you have a powerful mechanism, assuming you've got chromatography separation. Besides the isomers, if they colute, you've got a mechanism to identify and then create a method quickly with these tools. That's opposed to another game where you really don't know what you've got, you don't have the standards, and you're in much more of a discovery scenario. There are a number of distinct paths to creating the quant method, depending upon how much information you've got. So if you're in the discovery mode, you could use Qual. There's powerful interactive tools there, and once you've identified those compounds, you can take that information and move it to the quant method through a Chef file. I'll show you that in a moment. The Qual discovery to quant method development, you can see there are library searching tools in Qual, and that information can be pushed to quant to run quantitation workflows through this command here, available in the Qual menu. Worth mentioning that there is a navigation to the NIST tools. So in the Tools menu in Quant, under Actions, you can jump over to the NIST MS program, which has a set of tools. If you're familiar with those, that's a good place to look into using libraries and investigating a unit mass issue. Also seen here is the navigation to the sister Mass Hunter qualitative analysis application. Another path is you've got a current method and you have an issue with compound identification. Maybe there's an interference and you wish to investigate that, potentially extending or modifying your method. In evaluating that method, the library method becomes very useful. If you have that set up, you have a navigation through the library menu to unknowns. In the context of your current sample and target compound, you can examine in detail any components which are found that potentially could be other compounds or interferences. Right, you might ask, how do I get that quantitation target information into unknowns? Well, a couple ways. From within unknowns, I can import the quantitation analysis. After I've finished quantitation, I've saved those results. That will bring both the method and some parts of the results into unknowns. Also, if I want, I can just take the target method as a standalone without the results, and the method will help me do the target matching. Since we're on the topic of importing information, let's talk a moment about exporting information. So I can export information, and if you think about it, the library method, the library contains spectra and ions, and the quant method contains identification of spectra and ions. Those ions are identified as target and qualifiers. So there's quite a bit of overlap between a library and a quant method. So from unknowns, once I've gotten components and library hits on those components, I can export that, of course, as a CSV, but I can also create a library from either the components or the hits. And I can also create a quant method which would identify the target as the strongest ion. And that's a mechanism for components and hits to turn into a quantitation method. couple words about the Quant Library Editor, where you can manage your reference or search libraries. There are some useful tools in here. For example, you can calculate the monoisotopic mass from the formula. That would give me the molecular ion, often appearing if there's no fragmentation in an EI spectrum. You can also synthesize spectra. So if you're on the LCMS side and you've got your molecular ion and some adducts, you can go and pick from your buffer system the kind of adducts that would be ionized and add them in here, and then you can create synthetically a library of a set of spectra that includes the adducts. One feature quite useful, you might not know, is that you can edit libraries. So the issue comes up when you load in, for example, a PCDL library or a NIST library into the library editor, and you can't write it out or can't edit it. And that's by design, because we expect those to be simply read-only. But you can actually take the entries that you want, maybe a subset from NIST, and highlight them, copy them into the clipboard, and bring them over to another instance of the library editor, which then allows you to edit them, and you could save them in a format if you want to pursue editing them in the Quant Method editor. Thanks for your attention.